February 19th, 43. Kummersdorf Proving Ground, Brandenburg, Germany. The captured Sherman tank sat under arc lights in the main testing hangar, its turret traversed to the side, gun elevated at 12 degrees. Major Klaus Becker circled the vehicle slowly, notebook in hand, pausing at the turret ring where a technician had removed an access panel to expose the mechanical systems beneath. What Becker saw there made no immediate sense. A black cylindrical housing mounted vertically beside the gun breech, hydraulic lines running to servo valves he didn't recognize, electrical cables feeding into a control box stenciled with English text, Westinghouse Electric Corporation. The technician gestured at the components with the careful precision of a man, explaining something he didn't fully understand himself. Herr Major, we believe this is a gyroscopic stabilization system for the main gun. The Americans appear to have installed it as standard equipment on all Sherman variants. Becker had spent 3 years evaluating captured Soviet tanks, analyzing British armor, documenting every technical detail that might reveal enemy capabilities or weaknesses. He'd never seen anything like this. Gyroscopes belonged in naval fire control systems, in aircraft instruments, in laboratory equipment, not in a 32-ton fighting vehicle designed to crash across broken terrain driven by conscript soldiers. This single piece of technology, dismissed by German engineers as theoretically interesting but practically impossible, would explain something that had troubled Wehrmacht tank commanders since the first encounters with American armor in Tunisia. Why German crews, following proper doctrine, found themselves taking fire before they could return it. Why American tanks seemed to aim faster, shoot faster, acquire targets with unnatural speed. The mathematics of tank combat were about to be rewritten, and the advantage belonged entirely to the Americans. The Sherman bearing serial number USA 3067982 had been captured intact near Kasserine Pass 3 weeks earlier, when its crew abandoned the vehicle after throwing a track during the American retreat. German recovery units, accustomed to finding Soviet tanks damaged beyond repair or British vehicles burning from ammunition fires, approached this prize with careful optimism. The engine turned over on the first attempt. The transmission shifted through all gears smoothly. The electrical systems functioned without fault. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Loading the Sherman onto a rail car bound for Kummersdorf required minimal preparation beyond refueling and basic inspection. The tank had been driven 215 kilometers from the capture site to the rail depot without a single mechanical failure, a journey that would have required multiple maintenance halts for any German tank of comparable weight. That reliability, impressive but not unprecedented from American equipment, masked a more profound technological gap that wouldn't reveal itself until German engineers began systematic examination of the fire control systems. Kummersdorf, located 25 kilometers south of Berlin, served as the Wehrmacht's primary testing facility for both domestic and captured equipment. Here, methodical engineers measured, tested, and documented everything from track tension to ammunition performance, producing exhaustive technical reports that circulated through Wehrmacht technical branches and armaments ministry offices. The Sherman was about to undergo the most comprehensive examination German engineering could devise, and what they would discover would force uncomfortable conclusions about American industrial capabilities. The initial inspection teams photographed every component from multiple angles, measured clearances with precision instruments, documented construction techniques that seemed impossibly straightforward compared to German methods. The turret immediately commanded attention. Electric hydraulic power traverse, rotating 360 degrees in 15 seconds. German Panther tanks, just entering production, required 18 seconds for full rotation with power traverse systems that proved notoriously unreliable under field conditions. When Panther power traverse failed, crews resorted to hand-cranking the turret at 0.36 degrees per revolution, 720 complete revolutions to traverse 360 degrees. The Sherman's turret kept working. The power traverse drew from a dedicated hydraulic pump that ran whenever the engine operated, providing consistent performance regardless of engine speed or combat damage to other systems. German engineers noted this redundancy with grudging respect. American designers had assumed things that would break in combat and built accordingly. German designers assumed proper maintenance would prevent failures and designed for theoretical optimal conditions. But the turret traverse, impressive as it was, merely set the context for the discovery that would dominate every subsequent technical report. The gyroscopic gun stabilizer represented technology German engineers had studied theoretically and rejected as impractical for field deployment. Seeing it installed as standard equipment in a mass-produced tank forced immediate reassessment of American engineering capabilities. The system consisted of three primary components working in integration: a single anticipatory gyroscope spinning at 10,000 revolutions per minute, mounted to sense vertical motion of the gun tube; a hydraulic servo mechanism that received signals from the gyroscope and generated corrective force through oil pressure; an electrical control unit that coordinated gyroscope input with gunner commands, ensuring the stabilization system assisted rather than fought against manual aiming. The entire assembly weighed less than 140 kilograms and integrated directly with the Sherman's existing hydraulic systems, drawing power from the same pump that rotated the turret. German engineers examining the installation marveled at the elegant simplicity of the integration. No separate power source, no redundant controls, just a black box that inserted itself between the gunner's hand control and the gun mounting, keeping the tube steady through motion that would normally make aimed fire impossible. Testing protocols began immediately with observation trials designed to document system performance under controlled conditions. Engineers mounted the Sherman on a hydraulic platform that simulated terrain motion, pitching and rolling the vehicle through angles and frequencies that replicated combat movement. The gun remained stable through motion that should have caused visible barrel oscillation. The gyroscope, spinning at 10,000 revolutions per minute, generated angular momentum sufficient to resist external forces trying to tilt it. When platform motion attempted to raise the gun barrel, the gyroscope resisted that tilt, generating a signal proportional to the disturbance. The hydraulic servo valve converted that signal into corrective pressure, driving a piston that pushed the gun downward, cancelling the upward motion before it became visible in the gunner's sight. Major Becker documented the system's response characteristics in his official report dated March 5, 1943. The American stabilization system demonstrates capabilities we have not achieved in any German armored vehicle. The gun remains within 1 degree of set elevation through simulated terrain motion, equivalent to cross-country speed of 20 km per hour. This represents accuracy sufficient for aimed fire against targets at 800 meters, while the turns. Vehicle maintains forward movement. The implications troubled German tank doctrine at its foundation. Every army in 1943, German, British, Soviet, American, accepted as fundamental truth that accurate tank gunnery required stopping the vehicle before firing. The physics seemed inescapable. A tank moving at 20 km per hour experienced constant motion from uneven terrain. The hull pitched over rises, dropped into depressions, rocked laterally from track throw. Mount a 3-meter gun barrel weighing 700 kilograms to that moving platform, and physics delivered its verdict. Accuracy beyond 200 meters became statistical impossibility. German tank crews trained extensively on the halt fire move sequence. Spot enemy armor, halt the vehicle. Wait 3 to 5 seconds for oscillations to settle. Allow the gunner to center his reticle. Fire. Advance or retreat immediately before return fire arrived. Those 3 to 5 seconds of vulnerability represented the price every tanker paid for accurate aimed fire. It was doctrine written in the wreckage of tanks that had tried otherwise. The Americans had apparently decided physics could be negotiated with through engineering. The stabilizer didn't eliminate motion. It compensated for motion faster than human reaction time could, keeping the gun steady through conditions that would make manual aiming impossible. The system wasn't perfect. Engineers noted that extreme terrain motion, exceeding the servo mechanism's corrective capacity, would cause the gun to oscillate despite stabilization. But under typical combat conditions, the gun remained remarkably stable. Field testing expanded beyond laboratory simulation to actual driving trials across Kummersdorf's proving grounds. German test drivers, accustomed to the heavy steering and frequent mechanical complaints of Panther and Tiger tanks, found the Sherman surprisingly responsive. The controlled differential steering required minimal physical effort. The synchronized transmission shifted smoothly without the double-clutching technique German tankers spent weeks mastering. The Continental R975 radial engine maintained consistent power delivery across varying terrain conditions, but the revelation came when firing trials began with the stabilizer engaged. German gunners, selected for their extensive combat experience, took positions in the Sherman's turret and attempted firing sequences that violated every principle they'd been taught. The test protocol was brutally simple. Advance towards stationary target panels at 20 km per hour over rough terrain deliberately graded to simulate battlefield conditions. Engage stabilizer. Acquire target through gunner's telescope. Fire while maintaining forward speed. Do not halt. Do not slow. Fire on the move. The first gunner, Obergefreiter Ernst Kohler, a veteran of the North African campaign with 11 confirmed tank kills, expressed open skepticism before the trial. Herr Major, this contradicts basic gunnery principles. Moving fire is desperation tactics, not precision engagement. Becker's response was measured but firm. Proceed with the test, Obergefreiter. Document what happens. What happened forced Kohler to reconsider everything he knew about tank gunnery. The Sherman accelerated to 20 km per hour. Kohler acquired the target panel at 600 meters through his telescope sight. The vehicle bounced over the rough terrain, the hull pitching and rolling exactly as expected. But through the telescope sight, the target remained remarkably steady. The crosshairs stayed centered on the aiming point through motion that should have thrown them completely off target. Kohler squeezed the trigger. The 75mm gun roared, the recoil rocking the turret slightly. The stabilizer absorbed the disturbance, bringing the gun back to the original aiming point within half a second. Through the clearing smoke, Kohler saw the impact point. Center of the target panel at 600 meters, fired while moving at combat speed over rough terrain. He fired again without halting. Another hit, this one slightly low but still within the target area. A third shot as the Sherman continued its advance. Another hit. Kohler's after-action comment appeared in Becker's report verbatim. I have never experienced gunnery performance like this. The gun stays on target through motion that should make aiming impossible. If American tank crews employ this system effectively, they possess first-shot advantage in every engagement. Our doctrine assumes all tanks must halt to fire accurately. The Americans have apparently eliminated that requirement. The testing program expanded through March and into April of 1943 as additional captured Shermans arrived at Kummersdorf from various theatres. Each vehicle underwent identical evaluation protocols, building a comprehensive database of American tank capabilities. The British had provided hundreds of Shermans to their armoured divisions, and several captured from British units in Tunisia reached German testing facilities. Every Sherman examined featured the same Westinghouse stabilizer installation, standard equipment, not an experimental system or limited deployment. Every tank off American production lines included this technology. German engineers attempted to understand why their own armor development programs had never pursued stabilization with comparable success. Gyroscope technology existed in German industry. Servo mechanisms were well understood. Hydraulic systems were mature technology. The components existed. The theoretical knowledge existed. What Germany lacked was the industrial base to manufacture precision instruments by the thousands with reliability that didn't require individual adjustment by skilled technicians. The stabilizer assumed mass production precision that American industry treated as baseline normal. The gyroscope had to spin at exactly 10,000 revolutions per minute within tight tolerances. The hydraulic servo valves required precise manufacturing to specific clearances. The electrical control unit contained components that demanded specialized production capability. Germany's industrial system, increasingly strained by Allied bombing and resource shortages, couldn't replicate the stabilizer at scale, even if they'd wanted to. The system required an automotive manufacturing base that Germany simply didn't possess. American civilian industry had produced automobiles by the millions before the war, developing mass production techniques that guaranteed interchangeable parts and consistent quality across vast production runs. Germany's automotive industry served a much smaller civilian market, with cars remaining luxury items for the wealthy rather than common possessions across all economic classes. That fundamental difference in industrial maturity translated directly into military capability. Americans built tank systems that assumed perfect interchangeability and consistent manufacturing quality because their industrial base delivered that as routine output. By late spring of 1943, Kummersdorf had accumulated enough data to produce comprehensive assessment reports that circulated through Wehrmacht technical branches. These documents, marked, classified, and intended for senior officers and armaments ministry officials, painted an uncomfortable picture of comparative capabilities. The Americans possessed fire control technology that gave their tanks first-shot advantage in combat engagements. German tanks, despite superior armor protection and more powerful main guns in vehicles like the Panther and Tiger, had to halt before firing accurately. That doctrine created vulnerability windows that American crews could exploit. The tactical mathematics were brutal. A Sherman crew with properly employed stabilizer could maintain suppressive fire while closing distance, forcing German crews to button up and limiting their ability to spot and coordinate. When the Sherman commander decided to make the killing shot and halted his vehicle, the gun was already on target. No aiming delay, no compensation for vehicle motion. Crosshairs exactly where the gunner had placed them seconds earlier. Squeeze trigger, fire. The entire sequence taking perhaps 2 seconds. The German crew, following proper doctrine, experienced a longer sequence. Spot enemy tank, halt vehicle, wait 3 to 5 seconds for settling, acquire target through gun sight, center crosshairs, fire. That 3 to 5 second difference might seem minimal. In engagements where both crews had clear shots and adequate ammunition, the difference was lethal. German field reports from Tunisia, Sicily, and early Italian campaign operations noted consistent patterns that now made tactical sense in light of Kummersdorf's technical findings. American tanks demonstrated abnormal accuracy when firing immediately after movement ceased. American crews seemed to acquire targets faster than combat conditions should allow. American tanks fired first in engagements where proper tactical positioning should have favored the defender. Wehrmacht tactical intelligence had attributed these advantages to superior American training, better crew selection, perhaps more practice time on their equipment. The technical reality was more disturbing. American tankers weren't necessarily better trained. They possessed better fire control technology that compensated for mediocre gunnery and delivered first-shot advantage to crews of average skill. German attempts to develop countermeasures faced immediate obstacles. Replicating the stabilizer required manufacturing capabilities Germany didn't possess and couldn't develop while fighting a multi-front war against enemies with vastly superior industrial capacity. Modifying German tank design to incorporate stabilization would require complete redesign of turret systems, fire control, and hydraulic power distribution. The Panther tank was already in production, rushed into service to counter Soviet 34 tanks. Significant design changes were impossible. The Tiger tank, impressive for its 88mm gun and thick armor, employed an entirely different turret traverse system that couldn't accommodate stabilization without fundamental redesign. And with fewer than 1,500 Tigers ultimately produced during the entire war, the vehicle represented a prestige weapon rather than the backbone of panzer forces. Stabilizing Tigers was pointless when Panzer IVs remained the most numerous German tank throughout the war. The only practical response was tactical adaptation. Wehrmacht training centers began emphasizing techniques that might negate American fire control advantages. Use terrain to minimize exposure time. Engage from prepared positions where first shot advantage mattered less. Force Americans to attack into killing zones where movement drew them into German guns. These were sound defensive tactics that leveraged Germany's decreasing strategic position, but they conceded the initiative. German armor doctrine, built on aggressive maneuver and offensive action, was being rewritten around the uncomfortable reality that American tanks could shoot faster. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The captured Panzer IV commander, Hauptmann Friedrich Weber, sat across the interrogation table from British intelligence officers in a prisoner-of-war camp near Tunis in May of 1943. His account, recorded in meticulous detail, would become one of the first eyewitness descriptions of what German tank crews experienced when facing stabilizer-equipped Shermans. "We followed proper procedure," Weber stated, his voice carrying, the exhaustion of a man trying to explain the inexplicable. "We spotted the American tanks at approximately 1,000 meters. We halted our vehicle. Our driver executed the stop perfectly. We waited the required time for settling. Our gunner, an experienced man with 14 confirmed kills, centered his sight picture and prepared to fire." The British officer interviewing him noted Weber's hands moving unconsciously through the sequence as he described it, a muscle memory illustrating doctrine that had failed him. "The American tank," Weber continued, "never stopped moving. We could see it clearly, advancing at speed across open ground. Our gunner reported ready to fire. Before he could squeeze the trigger, we took a hit to our front glacis plate. The round penetrated. Our loader was killed instantly. The American tank was still moving when it fired. This should not be possible." British intelligence officers heard similar accounts from dozens of captured German tank commanders through the spring and summer of 1943. The pattern was consistent and troubling from the German perspective. American tanks fired while moving and hit their targets with accuracy that violated every principle of tank gunnery that German doctrine accepted as fundamental truth. Wehrmacht tactical intelligence sections attempted to explain these observations through conventional analysis. Perhaps American crews possessed superior training in estimating lead angles for moving fire. Perhaps American optics provided better sight pictures during vehicle motion. Perhaps American ammunition demonstrated unusual accuracy characteristics. None of these explanations satisfied the experienced panzer officers who'd faced this capability in combat and survived to report it. The technical examination teams at Kummersdorf, working with captured Shermans through the summer of 1943, initially focused their attention on the automotive excellence that German engineers found so impressive: the transmission reliability, the engine endurance, the final drive durability. These characteristics dominated early reports because they represented quantifiable mechanical superiority that German industry acknowledged but couldn't match. The stabilizer system received attention as a curiosity, an interesting technical feature that American designers had included, but whose tactical significance wasn't immediately apparent to engineers conducting static testing. The gyroscope spun impressively. The hydraulic servo mechanisms responded precisely to control inputs. The electrical systems functioned reliably. German engineers documented these observations with professional thoroughness, but without understanding what this technology meant in actual combat employment. That understanding required input from combat veterans who'd experienced the stabilizer's effects firsthand. Men like Oberleutnant Hans Schäfer of the 2nd Panzer Division, brought to Kummersdorf in August 1943 specifically to observe testing and provide tactical perspective on American tank capabilities. Schäfer had commanded a platoon of Panzer IV tanks during the Tunisia campaign, surviving engagements against both British and American Sherman units. His combat report, filed after evacuation from North Africa, included detailed observations about American gunnery performance that tactical intelligence had flagged as requiring technical investigation. Engineers placed Schäfer in a captured Sherman's gunner position and activated the stabilizer system. They instructed the driver to move the tank across rough terrain at varying speeds, while Schäfer attempted to maintain aim on stationary target panels. The experience proved revelatory. "The gun stays on target," Schaefer reported after the first trial run. "Through motion that should make aiming impossible, the sight picture remains remarkably stable. When we halt the vehicle, the gun is already pointed exactly where I aimed it. There is no delay, no searching for the target, no compensation required. The crosshairs are on target the instant we stop." He requested additional trials, increasing speed and terrain difficulty, testing the system's limits. After each run, his assessment grew more concerned. If American crews employ this system effectively, they possess decisive advantage in engagement timing. They can maintain aimed fire throughout their approach, forcing us to button up and limiting our ability to spot and coordinate. When they choose to deliver the killing shot and halt their vehicle, their gun is ready immediately. We lose 3 to 5 seconds bringing our guns to bear after stopping. In tank combat, those seconds are lethal. Major Becker's supplemental report, dated August 27, 1943, incorporated Schaefer's observations with technical findings from systematic testing. The document's conclusions were unambiguous and deeply troubling for Wehrmacht. Armored doctrine. The American gyroscopic stabilization system provides tactical advantages that fundamentally alter engagement dynamics. Enemy crews can maintain suppressive fire while advancing, degrading our ability to coordinate defensive actions. Enemy crews achieve aimed fire capability immediately upon halting, eliminating the settling time our doctrine requires. Enemy crews demonstrate first-shot advantage in engagements where tactical positioning should favor the defender. These advantages derive not from superior crew training or better tactical employment, but from technology we cannot currently replicate at scale. The report circulated through Wehrmacht technical branches and reached senior panzer commanders by early autumn 1943. The response divided along predictable lines. Younger officers, men who'd faced American armor in combat and witnessed capabilities they couldn't explain through conventional analysis, accepted the findings as validation of their combat observations. Older officers, particularly those who'd built their reputations during the Polish and French campaigns, when German armor held technical superiority, resisted conclusions that suggested American tanks possessed meaningful advantages. General Heinz Guderian, Inspector General of Panzer Troops and the architect of German armored doctrine, received Becker's report with characteristic directness. His marginal notes, preserved in Wehrmacht archives, reveal a commander struggling to reconcile technical findings with tactical doctrine built over years of successful operations. Stabilization technology interesting but not decisive, Guderian wrote alongside the technical specifications. Proper tactical employment and crew discipline remain paramount. German crews must emphasize first-shot accuracy and superior positioning to offset any technical advantages enemy may possess. This response, reasonable from a commander responsible for maintaining morale and operational effectiveness, nevertheless missed the fundamental point that Becker's testing had revealed. The stabilizer didn't just provide technical advantage, it allowed American crews of average skill to achieve gunnery performance that only the best German crews could match through exceptional training and experience. The technology democratized excellence, making good enough crews nearly as effective as exceptional ones. The implications for force-wide effectiveness were profound. German panzer divisions relied heavily on a small number of highly experienced crews, aces who'd survived years of combat and accumulated dozens of kills. These men were irreplaceable. When they died, their expertise died with them. American divisions, by contrast, could field entire battalions of adequately trained crews, whose stabilizer-equipped tanks gave them first-shot capability, approaching what only German aces achieved through hard-won skill. Wehrmacht tactical doctrine adapted slowly and incompletely to this reality through late 1943 and into 1944. Field commanders issued guidance emphasizing superior positioning, ambush tactics from prepared defensive positions, and engagement at maximum range, where German guns could penetrate Sherman armor before American guns became effective. This was sound defensive doctrine that played to German strengths, but it conceded the initiative and acknowledged that German tanks could no longer maneuver aggressively against American armor with confidence in winning direct engagement. The stabilizer's tactical impact became increasingly clear as American and British forces pushed through Sicily and into mainland Italy through the autumn of 1943. German after-action reports from Italian theatre operations documented consistent patterns that field commanders found difficult to counter through conventional tactical measures. American Sherman battalions demonstrated ability to advance under fire while maintaining suppressive fire that degraded German defensive coordination. American crews fired immediately upon halting, often achieving first-round hits before German crews could return fire. American units recovered quickly from initial contact, adapting tactics within individual engagements in ways that suggested crews had confidence in their equipment's capabilities. A particularly detailed report from Hauptmann Otto Carius, a Tiger tank ace with over 100 confirmed kills, described an engagement near Anzio in January 1944 that illustrated the stabilizer's tactical effect even when German tanks possessed overwhelming technical superiority in armor and firepower. Carius's Tiger, positioned in a defensive fighting position with excellent fields of fire, engaged a platoon of advancing Shermans at 1,000 meters. The Tiger's 88mm gun could penetrate Sherman frontal armor at that range with certainty. The Sherman's 75mm guns could not penetrate the Tiger's frontal armor at any practical range. The American tanks, Carius wrote, did not halt when we fired. They continued advancing while returning fire. Their rounds could not penetrate our armor, but the volume of fire they maintained forced my crew to remain buttoned up. We could not use our commander's cupola for spotting. Our vision was restricted to periscopes. The Americans fired continuously while moving, then halted briefly to deliver aimed shots before advancing again. Carius's Tiger destroyed 3 Shermans during the engagement and forced the remaining tanks to withdraw. German tactical analysis would classify this as a successful defensive action, a clear victory for superior German technology. But Carius's personal assessment revealed uncomfortable truths about what the engagement actually demonstrated. We won the engagement because our armor was impenetrable to their guns and our position was excellent, Carius concluded, but the Americans' ability to maintain aimed fire while moving complicated our defensive action significantly. If we had been in Panzer IVs rather than a Tiger, or if the Americans had possessed guns capable of penetrating our armor, the engagement outcome would have been far less certain. Their fire control technology provides tactical flexibility that our equipment cannot match. This assessment from one of Germany's most experienced and successful tank commanders carried weight that no amount of technical reports from Kummersdorf could provide. The stabilizer wasn't just an interesting engineering achievement. It was a combat multiplier that affected tactical outcomes in ways that superior German gunnery skill and positioning couldn't always overcome. By spring of 1944, Wehrmacht armored forces faced a compounding crisis of capability across multiple dimensions. German tanks, particularly the Panther and Tiger, possessed superior armor protection and more powerful main guns than anything the Americans fielded. But these advantages came at the cost of mechanical reliability so poor that operational readiness rates frequently fell below 50%. Meanwhile, American tanks demonstrated automotive reliability that kept them operational, fire control technology that gave them first-shot advantage, and turret traverse systems that allowed rapid target engagement. The mathematical reality facing German tank commanders became brutally simple. A Panther with a superior gun that broke down before reaching the battlefield contributed nothing to defensive operations. A Panther that reached the battlefield but required 5 seconds to bring its gun to bear after halting often faced American crews who'd already fired. A Panther whose power traverse failed, requiring manual turret cranking in close combat, became nearly helpless against Shermans that could traverse electrically at 20 degrees per second while keeping their guns stable through gyroscopic stabilization. German tankers captured during Normandy operations in June and July 1944 provided the most detailed first-hand accounts of what facing stabilizer-equipped Sherman battalions felt like from inside German tanks. These interviews, conducted by Allied intelligence officers, revealed consistent themes about tactical disadvantages that German crews struggled to overcome. Unteroffizier Karl Brenner, a Panther gunner with the 2nd Panzer Division, described the psychological impact of facing an enemy who could shoot faster. "You know you have the better tank," Brenner stated. "Your armor is thicker, your gun is more powerful, but they fire first, every time. You spot them, you halt, you're settling your sight picture, and they're already shooting. Sometimes their round bounces off your armor and you survive to return fire. Sometimes it finds a weak point and you're done. But they always shoot first." This testimony encapsulated the fundamental tactical problem, the stabilizer created for German armoured operations. Even when German tanks possessed superior technical specifications in armour and firepower, they couldn't reliably achieve first-shot advantage because American crews with stabilizers engaged had eliminated the aiming delay that German doctrine accepted as unavoidable. The broader strategic implications became impossible to ignore by summer 1944, as Allied forces broke out from Normandy and began the pursuit across France. American armoured divisions sustained continuous operations that German panzer divisions simply could not match. The combination of Sherman mechanical reliability, allowing sustained movement without maintenance halts, and stabilizer-equipped gunnery, allowing effective fire throughout movement, created an operational tempo that German forces couldn't counter. Wehrmacht intelligence reports from August 1944 analyzed American armored operations with professional thoroughness and reached conclusions that senior commanders found difficult to accept. The Americans weren't winning through superior tactics or better-trained crews. They were winning through industrial capacity that produced overwhelming numbers of reliable vehicles equipped with technology that provided tactical advantages German tanks couldn't match. The final German assessment of Sherman's stabilizer capabilities appeared in a classified technical intelligence summary dated September 15, 1944, distributed to senior Wehrmacht commanders and armaments ministry officials. The document's conclusions represented the most comprehensive official acknowledgement of American technical superiority in tank fire control systems. Enemy tank fire control demonstrates consistent advantages in engagement timing and first-shot capability. These advantages derive from gyroscopic stabilization systems that maintain gun alignment during vehicle movement. German industry cannot replicate this technology at scale with available resources and manufacturing capacity. Tactical countermeasures, emphasizing defensive positioning and maximum engagement range, provide partial mitigation but cannot eliminate enemy advantages. Continued operations against numerically superior enemy forces equipped with stabilized fire control systems will result in unsustainable attrition rates for German armored forces. This assessment, written in the carefully neutral language of official military documentation, amounted to acknowledgement that German tanks had lost technological parity with American armor in the one category that mattered most for tactical effectiveness, not armor protection, where German tanks still held advantages, not gun power, where German tanks remained superior, but in fire control, the ability to shoot first and hit consistently. American tanks with properly employed stabilizers had achieved decisive superiority. The human cost of this technological gap played out across every front, where American and German armor met through the final year of the war. In the Ardennes during December 1944, when German forces launched their final major offensive in the west, Sherman crews with stabilizers engaged achieved first-shot rates exceeding 65% against German armor. In the Rhineland during February and March 1945, American tank battalions advancing into Germany reported kill ratios approaching 4-1 against defending German tanks, despite German advantages in terrain and tactical positioning. These outcomes reflected multiple factors, including overwhelming American numerical superiority, air supremacy, and artillery support. But the stabilizer's contribution remained consistent across all engagements. American crews shot faster, hit more frequently, and survived longer because their fire control technology functioned exactly as designed, while German tanks, for all their impressive specifications, continued suffering from mechanical unreliability and fire control systems that required complete vehicle halt before accurate fire could be delivered. The final validation of the stabilizer's tactical importance came not from American assessments, but from German crews who'd used captured Shermans in combat operations. The 10th SS Panzer Division's experience operating 12 captured Sherman tanks during the final months of the war provided the most comprehensive German perspective on what American fire control technology meant for crew, effectiveness, and survival. Obersturmführer Michael Wittmann, commanding one of the captured Shermans in early 1945, filed a combat report that reached Wehrmacht archives before Germany's surrender. His assessment was unequivocal. The American tank's fire control system represents fundamental advantage that our vehicles do not possess. The gun remains stable during movement, allowing aimed fire without halting. When we do halt to deliver killing shots, the gun is already on target. This eliminates aiming delay entirely. German crews operating these captured tanks achieve engagement timing and hit rates comparable to our best aces. This is not due to superior crew skill. It is due to superior fire control technology that makes good crews excellent and excellent crews unstoppable. Wittmann's report noted that crews transitioning from Panthers to captured Shermans required minimal adaptation, a time to achieve high effectiveness with the stabilizer system. The technology worked as designed, requiring only basic training and proper maintenance to deliver its tactical advantages consistently. This observation highlighted perhaps the most significant aspect of the stabilizer's impact. The system wasn't temperamental or unreliable. It didn't require exceptional crews to employ effectively. It simply worked, mission after mission, engagement after engagement, providing the same first-shot advantage to every crew that learned to trust it and use it properly. By April 1945, as German resistance collapsed across all fronts, the stabilizer's role in Allied victory had become clear to anyone who'd experienced tank combat from either side. The technology hadn't single-handedly won the war. No single weapon system ever does. But it had provided American armor with tactical advantages that German tanks couldn't match through crew skill or tactical employment alone. The stabilizer allowed average American crews to fight effectively against experienced German crews. It allowed American armored divisions to sustain operational tempo that German panzer divisions couldn't maintain. It provided first-shot advantage in thousands of individual engagements where firing 2 seconds faster meant survival versus burning. German engineers at Kummersdorf, examining captured Shermans through years of systematic testing, had understood the technology's significance by mid-1943. They documented it thoroughly, explained it clearly, and communicated their findings to Wehrmacht commanders and armaments officials. But understanding a problem and solving it proved to be entirely different challenges when industrial capacity, resource availability, and strategic circumstances conspired against effective response. The gyroscopic gun stabilizer, that 300-pound black box that Clinton Hanna had developed in 18 months of obsessive engineering, represented exactly the kind of practical, manufacturable technology that American industry excelled at producing and German industry struggled to replicate. It didn't require theoretical breakthroughs or scientific innovation. It required precision mass production, reliable component manufacturing, and industrial systems that could deliver consistent quality across tens of thousands of units. These were capabilities that American automotive industry had developed over decades of civilian production, building cars and trucks by the millions for a domestic market that demanded reliability and affordability. German industry, lacking comparable civilian automotive base, couldn't match American manufacturing maturity, even when German engineers understood exactly what needed to be built. The final irony was that German tankers, capturing and operating American Shermans in the war's final months, universally praised the stabilizer's effectiveness, while simultaneously acknowledging that German industry could never have produced it at the scale and reliability American factories achieved. The The technology that gave American tanks their decisive edge in fire control wasn't exotic or impossible to understand. It was simply impossible for Germany to manufacture in the quantities needed while fighting a losing war on multiple fronts against enemies with superior industrial capacity. The Sherman tank's legacy in armored warfare history rests not on individual technical superiority in any single category, but on integrated advantages that compounded into decisive tactical effectiveness. Automotive reliability that kept tanks operational. Turret traverse systems that allowed rapid target engagement. Gyroscopic stabilization that eliminated aiming delay and provided first shot advantage. These capabilities, working together, made the Sherman greater than the sum of its parts and gave American armor the tools it needed to win the ground war in Europe. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.